Plan. So good morning guys, welcome to digital system design classes. So in this video lecture I am going to explain about introduction hardware description language and introduction to FPGA and what are the blocks in FPGA. So coming to VHDL, it is a hardware description language which will describe the behavior of the structure. Means HDLs are used to describe the structure of the whatever the digital circuit we are using. It is not possible with in software programmings. So mainly VHDLs, we have different types of HDLs. So we use HDL, VHDL and Verilog. So VHDL stands for very high speed integrated circuit hardware description languages, whereas Verilog system is just Verilog HDLs. So hardware descriptions languages are extremely important tools for modern digital designers. So nowadays, if we want to design any hardware circuitry, we use VHDLs. VHDL or Verilog means HDLs. The most important thing to remember when you are writing HDL code is that you are describing real hardware, not writing a computer program, right? So we are not writing any computer programming. So we are writing hardware circuitry. So using HDL, it is allowed. HDLs are used for both simulation and synthesis. Logic simulation is a powerful way to test a system and a computer before it is turned into hardware. So before it is whatever the code we are writing, so we need to check the inputs and outputs. So by giving different input combination, we will check the output in software. So that is known as simulation, whereas logic synthesis converts the HDL code into digital logic circuit. So whatever the code we have written, we can synthesis convert that HDL code into digital logic circuits. So it is the history of VHDL or Verilog. In 1980s, we have developed, IEEE has developed VHDL. So in 1987, IEEE adapted the VHDL language and as a standard 1076. It was revised in 1993 as the standard VHDL 93. So there are some modifications as done in VHDL 87 in 1993. So it is VHDL 93. So Verilog HDL and a simulator were released by Gateway Design Automation in 1983. So there are some differences between VHDL and Verilog. So VHDL is case sensitive, whereas VHDL is case insensitive, whereas Verilog is case sensitive. So any programming languages, we have keywords. So in VHDL, whatever the keywords we are using, we can write those keywords in uppercase or lowercase or combination of both are allowed in VHDL. So whereas in Verilog, as it is a case sensitive, so whatever the keywords we are writing, so all the keywords are only in small case. So and VHDL is very difficult to learn, Verilog is very easy to learn. So why? Because VHDL program structure is divided into two parts, entity part and architecture part. So what is entity means? Entity will give the information about external signals like inputs and output, and architecture will give the information about internal structure, right? So what gate we are using, how it performs, all those things we are going to write in architecture, whereas entity will be defined only how many number of inputs and output to the block diagram. So whereas Verilog, we can write the program using end module and using end module. So it is very simple. Design is composed to a module which have just one implementation. So and one more important point is, so libraries and package declaration is present in VHDL. So we need to define library and which package we are going to use in VHDL. So any VHDL programs, first statement is library IEEE, then use IEEE.std logic 1164.all, then entity part, and then architecture part. So whereas coming to Verilog, there is no library and package declaration is present. So VHDL code, as I told, so we need to define library, packages, entity, architecture. So the program is very bulky in VHDL. So whereas Verilog is very easy code. So there are a lot of differences between hardware and software languages, which I discussed just now. So HDL defines the structure and behavior of electronic circuits, whereas software program is write a set of instructions to allow the CPU. So VHDL's this design is based on creation and use of textual based description circuits, whereas software is used to create executable software applications that will operate on suitable processors. So example for HDLs are Verilog HDL and VHDL, and software language programs are C, C++, Java. So next, coming to FPGA. FPGA stands for Field Programmable Gate Array. So the first FPGA was introduced by Xilinx in 1985. So we have VHDL in 1983. So Xilinx means FPGAs can be operated only with the help of HDLs, right? So we cannot use C and Java or etc. software programs in FPGAs, right? So the main FPGA is developed by Xilinx in 1985. So it has arrays of logic blocks which are programmable. It is supported by programmable routing sources, which allows the user to define the interconnections between the logic blocks. It also has lots of very flexible input and output circuits. So mainly FPGAs has 4 blocks. So first one is CLB, so which is known as configurable logic blocks. Second one is IO pads, so which we can connect input and output devices using these IO ports. And internally we have interconnecting wires and switching matrices. So switching matrices are connected to CLBs. So these switching matrices will take the inputs and generate connect CLBs. So nowadays there are 2 major players in FPGA domains. So FPGA domains mainly Xilinx and Altera. So these 2 companies dominate 90% of FPGA market with roughly equal share. So mainly FPGAs can be dominated by Xilinx and Altera. So this is the block diagram of FPGA. So as I told, FPGA contains thousands of CLBs. Each CLB will have several basic logic elements, which is also known as BLE. Basic logic elements consist of a lookup tables for implementing combinational logic, and a memory element known as a flip-flop, and number of multiplexers, right? So this is the block diagram of a CLB, right? So any CLB has 3 blocks. So CLB, so lookup table, flip-flop, and multiplexer. So these are the 3 blocks in CLB, and we have switching block, which is used to connect the circuitry. So the wires connecting the various CLBs can be programmed as well as through a series of switching boxes in the routing channels. A high-level description languages such as VHDL or Verilog is used to describe how an FPGA is used to be configured. Is it clear? So FPGAs can be described using VHDL and Verilog. So these are the blocks in FPGA: CLBs, IO pad. So IO pad we can connect input and output devices, switching matrix, and routing channels. So this is a general block diagram of FPGA. So write whatever the blue lines. So these blue lines are CLBs. So these are black lines are connecting wires. So these are the IO pad. Right? These are the IO pads. So combining idea from programmable logic devices and gate arrays. So this is mainly we have ASICs. So what is ASICs means? Application specific integrated circuits. So these are nothing but FPGAs are programmable ASICs. So we can reprogrammable ASICs. We can call FPGAs as reprogrammable ASICs also. If we want to change any program, we can change that program using FPGAs for ASICs. So first PLDs are PLDs. First programmable devices are programmable logic devices. Then CPLDs. Later we have FPGAs. So FPGAs are firstly introduced by Xilinx in 1985. So here we have, so as I explained earlier, we have CLBs, IO pads, switching matrix, routing channels. So FPGAs mainly developed by two domains, Xilinx and Altera. So other specialists are Actel and Lattice Logic. So 90% FPGAs can be developed by Xilinx and Altera, then remaining 10% by Actel and Lattice. So this is the block diagram of a configurable logic block. So as I explained earlier, any configurable logic blocks has three parts. So first part is lookup tables. So used to store the addresses. So and second part is flip-flops. So what lookup tables output is given to flip-flops, and we have a multiplexer. So multiplexers we give lookup tables outputs or flip-flop outputs. So based around lookup tables. So these are used mostly commonly used lookup tables are 4 inputs. So we use flip-flop as D flip-flop, as we have 4 types of flip-flop: SR, JK, T and D. In CLBs we use D flip-flop, and we have a multiplexer. So then we have programmable routing. So this red arrow mark indicates, so if we want to connect, we can connect. If we want to if we want not connect, we can release that connection. So these are the, so between rows and columns, so rows and columns we have a switching matrix. So all the connections are connected to the switching matrix. So these are programmable, and a logic block pin can be connected to one of many wires tracked through a programmable switch. Xilinx FPGAs have dedicated switching block circuit for routing. So these switching matrices are used to do FPGA more flexible. Each wire segment can be connected in one way. So like this. So we can connect wire using many ways. So next one is, right. So this I'm going to explain one more time. So FPGAs as 4 blocks. Configurable logic blocks. In configurable logic blocks, we have 3 blocks: lookup tables, LUTs lookup tables, flip-flops. We use flip-flop as D flip-flop, and multiplexers. And we have IO pads. So using these IO pads, we can connect input and output devices, and switching matrix. So whatever the routing channels are connected to the switching matrix. So switching matrix will take the input, and it will connect it to the CLBs. So right. So this is about this class. In the next class, I'm going to explain about different types of VHDL. Thank you so much.